Okay guys, so today we're going to be having a look at serial and parallel circuits to remember some of the technical concepts that we need to study and to review for our exam, okay? So basically what do we have in here? We have, remember, our breadboard or protoboard, yeah? So is where we are going to be having our circuits connected, yeah? Remember that we are going to be having a positive and a negative lane, yeah, that share all of the energy across all of this column, if you want to call it like that. Yes, this is going to be positive. And of course, this one that we have in here is going to be completely negative, yeah? Also remember that inside of a breadboard, the connections are shared, yes, by rows. So for example, if I connect something, this little dot over here, all of this row is going to be connected to the same source, to the same signal, okay? And remember that we have all of these number and with some coordinates, yeah? For example, this is 5A, 5B, 5C, 5D, 5E, and so on and so on and so on, okay? So basically, today we're going to be having a look at this circuitry that we have created over here. What can we see? Basically, we're going to have some DuPont wires, yes? These are DuPont wires. We have some LED, yeah, red, yellow, red, and green, and so we have some resistors. Especially this is 330 ohms of resistance, so that we can make sure that we control everything. Yes. So guys, remember, whenever we need to talk about serial and parallel elements, yes, we must talk about the way they share the current and they share the power. Yeah. So what do we have right here? Look, if we pay attention, we have this standard, yes, that we discussed in class. We have red for positive, yeah, and black for negative, yeah, if you see right there. So all of this lane is charged positively and all of this one is charged negatively, yeah. If you pay attention, yeah, look here, I have a resistor, yeah, connected to a negative lane, and the resistor is also connected, yeah, to the, let's see, to the negative of the LED. Remember, when we talk about LEDs, we must talk about positive being the longest leg and negative being the shorter one, yeah? So we can reconnect it over here. If you pay attention, and connecting the negative to 50C, yes, and the positive to 49C, yeah? So in that way, yes, let's move this resistor out of the way, yeah. This is in negative and it shares the negativity, yeah, polarity to this LED leg. And at that moment, the positive is going to be shared again to the positive polarity of the LED, of the second LED. In this case, we're discussing or we're talking about a parallel series, okay, parallel circuit. Yes, this is one example of parallel. So all of these 6 LEDs, they're connected using a parallel structure. It doesn't mean parallel. That if one of the elements, yeah, gets broken or damaged or removed out of the structure, all of the elements should still be able to work. Yes. That's the main element in parallelity. If one of the lanes that's carrying electricity breaks, the circuitry should continue working. Yeah. So this structure works pretty much the same in all of the scenarios. As you see, all of the transistors connected to the negative lane and to the negative leg of the LEDs, and the positive one is connected, of course, to the positive of the other LEDs. Yeah. To test this, yes, let's connect it to our power sources. Yes, in this case, I'm going to be using a 3 volts pack of batteries. Yeah, of this is double A batteries. Yeah, so it has 1.5 volts, and since it's in 2, it means that we're having 2 volts. Yes, I'm going to be using the DuPont connections, these ones, to be able to connect it to the corresponding lanes. So as agreed, we are going to be having negative in black and positive in, of course, red. Look, yes. Why is it happening like that? Why is it that our LEDs are not so shiny and bright? Well, because of the voltage, yeah. Remember that in order to have an LED turned on, we need 1.7 volts, so that's pretty much what we can have. However, we can, for example, use an Arduino, yes, to create more power. So let's use this black is for ground, and of course we're going to be having our standard of red for 5B. Yes, this is going to be 5B, as you may see in here. And let's do the same. Let's just change the connection over here. May connect them wherever I want. Black for negative and red for positive. Of course, I need to connect the Arduino to the power. I'm going to be using its main power source. That is going to be a power battery, yeah, a power bank. And just by pressing this button, I am able to start all of the alarms, yes? So, how is a positive way to determine that everything is in parallel in here? Because the voltage here is going to be the same in all of the lanes. So, let's use our multimeter so that we can have a look at this, yes? So, remember, black for negative and red for positive, yeah? So let's change this one over here. So let's connect the negative to the positive. Let's do it the other way around so that we can get, for example, to this one and to this negative over here. So you see it's 2.0, yes, negative to positive. Let's test this one, negative with negative. That is again, let's see, I don't want to create the short circuit. That's 1.8. Let's go with this one. It's going to be 2, yes. And let's test, for example, this one at the end. That's going to be also 2, yeah. So that's the way in which we determine that it's working in parallel world, okay. Now, if we want to discuss serial, yes, serial ones, yes, have a look at this one. I have everything organized and arranged so that you can see clearly, yes. Now let's change to the serial one. What happens, yeah, what is that happens in the serial one? There's only one lane in which electricity is flowing. In this case, negative to positive, positive to negative, and of course positive, yeah. So let's work on that. Let's change our frame right there. So what's going to be the deal in here? Let's connect again. Positive to positive and negative to negative. In this case, apparently this is not working. Let's debug. Let's determine why. If you have a look at it here, yeah, this LED is connected to nowhere in the positive. Yeah? So let's use a DuPont wire. These are the DuPont wires that we have in class, DuPont, yeah. Let's just have one. We connect the positive, this one, yes, that's 40, that's 14, actually. And we connect it to our positive, yeah. So in this way, now, yeah, there's only one series, yeah. What happens in the series? If I remove, for example, this LED, my system stops working, yeah. If I connect it back, it doesn't matter, okay? Yeah, that's something that doesn't happen, yeah, if we want to test it in this, in the serial one. That's something that doesn't happen, yes, in the series circuit. Why? Look, that one that we have in the background is our series circuit. Let me just adjust it. Yes. Let's suppose that I want to remove this one. Look, you see, everything continue working as well. If I want to remove this, that one, you see, others continue working. Let's suppose that I want to remove this one. Look, I remove it completely and the others are still working. Yes. And as soon as I put it back, it starts working again. That's something that doesn't happen in this series. That is the one that we have over here at the bottom. Look, I remove this one, the circuit goes bye-bye. Yeah, if I connect it back, it's going to be having, again, the electricity that we need. Yes. So let's suppose that we want to test, yes, the power that is being shared. In a series circuit, the power gets shared, okay? So it gets divided among all of the connections. So positive, negative in here, and positive in here, and it's giving a reading of 2.2. Yes, let me put it there. That's 2.2, yeah? And if I want to test the other one, yeah, it's going to be 2.3, yeah? Why? Because I'm have connected to the 5B. So that creates like the whole series, okay? So that will be it, guys. I hope that you have learned. Of course, really important, have a look at all of the circuitry, the resistors, the LEDs, negatives, yes, positives, and of course the way that we connect it. Bye bye.